Welcome to our channel. Let's begin the journey.
Today, we are diving into one of the oldest, most mind-boggling mysteries of our universe. How do stars actually shine? I mean, for thousands of years, humans have looked up at those brilliant little points of light in the night sky and honestly just drew a complete blank. So let's figure out how this massive puzzle was finally solved.
It's a pretty profound question, right? We just kind of take for granted that the sun is going to rise and warm us up every single day. But how does something burn so consistently for literally billions of years out in the freezing vacuum of space? Now, by the early 20th century, scientists were actually using spectroscopy to figure out exactly what stars were made of, but they were still entirely powerless to explain how they actually burned.
Which brings us to part 1, the mystery of starlight.
And that leads right into part 2, the false gravity hypothesis.
So get this. At the time, the leading scientific hypothesis was that the sun shined simply because of gravitational contraction. Basically, the idea was that it was slowly crushing inwards on itself, and that friction was generating heat. But there was a massive problem. The math produced an absurdly short lifespan. We're talking maybe a few tens of millions of years. And this fiercely clashed with what geologists were saying because they had already proved the Earth was billions of years old. Obviously, our planet couldn't be older than our star. This was a huge paradox, and it desperately demanded a visionary to solve it.
Which brings us to part 3, Bethe's cosmic alchemy.
And that visionary? That was theoretical physicist Hans Bethe. By taking the absolutely cutting-edge science of quantum mechanics and applying it directly to the stars, he discovered a process he called cosmic alchemy. He finally proved to the world that it wasn't fire as we know it, and it definitely wasn't gravity. Stars are actually the universe's ultimate manufacturing plants, forging fundamental elements right there inside their insanely dense cores.
Let's dive a little deeper in part 4, the giant nuclear reactor.
Okay, so here is the absolute game changer. Bethe showed that every single star you see in the sky is, in reality, a giant nuclear reactor. Deep within our sun's core, the temperature and pressure reach these just terrifying, unimaginable extremes. Under those conditions, hydrogen nuclei don't just, float around, they violently smash into each other, fusing together to form a heavier element, which is helium. This highly energetic nuclear fusion is the exact, literal mechanism that is powering our entire world.
Now, when those hydrogen nuclei fuse into helium, a really tiny bit of mass is actually lost in the process. But it doesn't just vanish into thin air. Oh no, it is converted entirely into a colossal, massive amount of energy. Bethe beautifully laid it out for everyone, showing that starlight is actually a perfect, real-world application of Albert Einstein's super-famous mass-energy equation, E equals mc squared.
But that leads us to a much darker question in part 5, when the engine stops.
Seriously, think about it. What exactly happens when that immense nuclear reactor finally runs out of its hydrogen fuel? Because, when the cosmic alchemy eventually stops, gravity's just waiting right there to take over. To answer this, we look back to 1930. A 19-year-old kid named Subramanian Chandrasekhar was literally sailing on a boat from India to England. Armed with nothing but some scratch pads, he sat down and performed these insanely complex calculations to figure out the ultimate physical fate of dying celestial bodies.
Up until then, scientists basically assumed dead stars just gently cooled off into these dense objects called white dwarfs. But Chandrasekhar mathematically proved that the only thing holding up the crushing weight of a dead star is this microscopic, highly delicate quantum phenomenon. It's known as the degeneracy pressure of electrons. Basically, you can think of it as a tiny, invisible quantum shield.
But here is the catch. His math revealed a completely inescapable limit. He found that if a dying star's remnant exceeds 1.4 times the mass of our own sun, a hard boundary we now actually call the Chandrasekhar limit, well, that delicate quantum shield completely fails. It just breaks. Gravity wins the tug of war, the star absolutely cannot exist as a white dwarf anymore, and it must inevitably collapse in on itself.
And this massive realization paved the way for another incredibly famous mind, J. Robert Oppenheimer. Now, long before he was working on the Manhattan Project, Oppenheimer directed his formidable intellect right at astrophysics. He dared to ask the next logical question: what exactly happens when a really massive star dies and gravity just completely and utterly overpowers that dying core?
Through some profoundly complex calculations, Oppenheimer vividly described a total, catastrophic gravitational collapse. He realized that if a star is massive enough, there is literally no natural force in the universe that can resist its gravity. The core continuously compresses down to an infinite density. It shrinks so intensely that the matter actually pierces the fabric of space-time itself. It creates a bizarre region where extreme gravity outright forbids everything, even light, from escaping. And there you have it, the foundational understanding of what we now call black holes.
All of this brings us to a super humbling realization, doesn't it? The only thing keeping the blazing stars in our sky right now from just collapsing under their own immense weight is Hans Bethe's delicate cosmic alchemy, that frantic, continuous fusion of atoms in the dark. So next time you look up at the night sky, I want you to ponder this. When that nuclear fuel finally runs out and gravity inevitably takes over, what other strange, terrifying, and completely invisible monsters are quietly waiting for us out there in the deep cosmos?
The view from here is breathtaking. Command, we are in position and ready for the next phase. If you liked the video, subscribe and comment the topic you want next. Thanks for watching, and stay unstoppable.